RAG agents are powerful because they reach beyond the model. That same reach creates risk. In this lesson, we'll learn how to control what they retrieve, what they trust, and what they're allowed to reveal. Before we focus on RAG security, let's connect the path so far. We started with agent risk and threat modeling, then tightened tool permissions and isolation. We also examined prompt injection and exfiltration. Now those defenses meet retrieval, where documents can shape an agent's decisions. RAG changes the security model because the agent is no longer reasoning only over the user request and trusted system instructions. It also consumes documents, search results, and embedded content that may come from outside your control. That retrieved context can influence decisions, tool calls, and final answers. A poisoned document might say, ignore previous rules, or quietly push the agent to leak data. Vector search adds another risk, surfacing content the user is not allowed to see. Treat retrieval as an untrusted input pipeline until it is validated. In a secure RAG pipeline, retrieval is not just about relevance. Each candidate document needs a trust classification before it reaches the prompt. An approved internal policy may be high trust, current, and broadly usable. A customer contract may be authoritative, but confidential and limited to specific users. A public forum post may be fresh, but weak provenance limits how much it should influence the answer. The key is to combine source, sensitivity, freshness, and authorization into one decision. Can this content be used, and under what constraints? A retrieval system can only enforce policy if the right metadata is captured before content is indexed. Fields like tenant ID, owner, access group, classification, source, timestamp, and review status become the control plane for retrieval. They help determine whether a result is authorized, redacted, or blocked. Security-critical metadata should come from controlled ingestion services, not from user-written document text. And when metadata is missing or unclear, the safe behavior is not to guess. Default to deny or quarantine until the document is reviewed. Before a document can shape an agent's answer, it needs a trust trail. Provenance records capture the source system, uploader, lineage, checksum, and ingestion path, so we can prove what entered the pipeline and whether it changed. Freshness checks then ask, is this version current, expired, superseded, or confirmed by an authoritative source? Anything stale, conflicting, or unverifiable should be rejected or quarantined before indexing. The practical rule is simple. When retrieval supports real decisions, prefer authoritative enterprise sources over duplicated, scraped, or user-supplied content, even when the text looks relevant. Document-level access control has to happen before retrieval results enter the model's context. The unsafe pattern is to search everything first, then filter afterwards. That can expose sensitive chunks through ranking, logging, caching, or prompt construction. The safer pattern is authorization first retrieval. Every query carries metadata filters such as user, group, role, tenant, classification, and document permissions. The vector store or retrieval layer searches only within that allowed scope. Apply the same rules to index chunks, not just parent documents, so the model receives only content the requester is permitted to see. Vector search needs authorization built into the search path, not added as an afterthought. Each document chunk should carry the access metadata of its source, such as tenant, role, group, and classification. When a user asks a question, their auth context becomes mandatory filters on the vector query, not optional post-processing. The same rule must hold through hybrid search, re-ranking, context assembly, and caching. Avoid one global index for sensitive data unless every retrieval path is strongly partitioned or filtered. Semantic relevance only matters after the result is authorized. In multi-tenant RAG, isolation has to be engineered into every step, not delegated to the model. Each customer, department, or project needs a trustworthy boundary, using separate indexes, namespaces, collections, or strict tenant filters based on risk. That boundary must hold during ingestion, indexing, retrieval, re-ranking, caching, logging, and final response generation. Pay special attention to caches and summaries because they are derived data and can leak context. If tenant A can ever retrieve tenant B's content, that is usually a system design failure, not a prompt failure. At retrieval time, authorization has to be rebuilt from trusted server-side context, not from the user's wording. First, authenticate the user and capture session. role, tenant, and active policy. Then convert that context into enforceable filters, such as allowed tenants and clearance limits. The retriever applies those filters before search, so unauthorized documents are never candidates for ranking or generation. If the user tries to override access through the prompt or tool arguments, ignore it. Finally, log the context and policy used, so every retrieval decision can be audited. Treat every incoming document as untrusted until it passes inspection. Before text extraction and embedding, validate the file type and run malware scanning. Then inspect the extracted content for prompt injection phrases, hidden instructions, encoded text, suspicious links, redirects, and embedded payloads. The results should drive policy decisions. Quarantine clearly malicious files, sanitize risky content when appropriate, and attach security labels such as suspected prompt injection, untrusted source, or requires review. Those labels let Retrieval apply stricter controls later. Over time, feed outcomes back into detection rules so the ingestion pipeline continues to improve. Think of retrieved documents like evidence in a courtroom. Evidence can inform the case, but it does not get to become the judge. System and developer instructions set the rules. The user request defines the case. Retrieved text is only data. Only trusted, authorized sources can define behavior. At runtime, keep those context boundaries clear. If a document says ignore previous instructions, asks for secrets, or tries to steer tool use, treat that as suspicious content, not a command. The agent can downgrade its trust, suppress it, summarize it safely, or refuse to use it. When retrieved content contains risk, the goal is not always to discard it. Start with a safety gate, then choose the least restrictive pattern that still protects the system. Sanitization removes things the agent must never execute, such as hidden instructions, unsafe links, secrets, or control language. Summarization keeps the useful meaning, but converts it into neutral facts, not commands. Refusal is appropriate when the content is malicious, unauthorized, or policy violating. For high-impact or ambiguous cases, escalate to a human reviewer before use. Secure RAG works when every step is policy-aware. Content is scanned, classified, and either indexed with strong metadata or quarantined. At query time, retrieval is not just similarity search. It is filtered by identity, role, tenant, trust level, and policy. The context builder then isolates retrieved text, redacts sensitive data, enforces token and trust limits, and refuses unsafe requests before the agent responds. Validation should attack the system directly. Unauthorized access, tenant leakage, poisoned documents, stale content, and prompt exfiltration. Finally, logs and metrics make the architecture auditable and improvable. Secure RAG comes down to 3 controls: curate what enters the corpus, enforce who can retrieve each document, and define how risky or malicious content is handled after retrieval. Use trust, sensitivity, provenance, freshness, and authorization as design inputs. With retrieval secured, the next layer is controlled action, deciding when high-risk agent behavior requires human approval.